Okay, good. So V is equal to 0 at this point, and that's because it's continuously being decelerated as a result of gravity up to here. Okay, good. So that's that. So therefore, at this point, V0, so at this point is the actual velocity, right? The initial velocity U, and V0. Now, the time it takes to go up is actually the same time it takes to come back down because of this, again, here, it's going to decelerate back down, but uniformly, right? With that same 9.81. So the time it takes to go up is the same time it takes to come down. So the time to travel this length or this length up and down is actually equal to T divided by 2, which is 2 seconds, right? Now we can use this 2 seconds to find the velocity, find the initial velocity. Okay, good. So let's just put down a formula. We know V is equal to U plus AT. We transpose, this here is going to be minus A, right? So it'll be minus U over minus A is equal to, oh, actually it's going to be minus U is equal to minus AT, right? Minus U is equal to minus AT, and then the minus sign is just going to cancel out, right? But we can just like realize that it's acceleration by time, and we can use that to get velocity because it's linearly, right? It's decelerating uniformly. So we can just do U is equal to AT or V is equal to A times C, right? Just multiply acceleration by time instead of having to solve the entire formula. So plugging those values in, U is what we want to find. Acceleration is acceleration due to gravity, 9.81. And the time, as I said, because this path is symmetrical, right? We go up and then we come back down. So it's symmetrical. So we divide by 2, T divided by 2. Multiply 9.81 times 2 is equal to 19.62 meters per second. That's the velocity. So we did part B first, right? The reason we did part B first is because part B is easier, right? And we can use the velocity to find part A. Good. So part A, we know velocity now. We know U, initial velocity. U is equal to 19.62. We found that up here, right? Up here. Then we know time is 2 seconds. Time. Let me write this formula back. S is equal to UT plus half AT squared. Okay. We know U, great. We know T, great. We know acceleration, great. Plug all this into our formula and we get 19.62 meters. Right? Okay. And we can look at this again with just the velocity time graph. Okay. Yeah. So it's initially thrown at a velocity of 19.62. And at the top there, at the greatest height, the velocity is 0, right? So it comes down like this. And it does that in 2 seconds. So here, is essentially the area under this triangle, which is half base times height. So the height is 19.62 and the base is 2 seconds. So half of that is multiplying by 1. So the area of this is still just 19.62. And you shouldn't confuse that with it being something like this. You say we use 19.62 meters per second for 2 seconds, but that would be finding the area of this rectangle, which is different. Right? So 2 seconds, but it's decelerating uniformly. So just because this answer is here is that velocity, and this is 2 seconds, doesn't mean we need to multiply that by 2, right? And that's why this formula exists, right? So these answers are the same thing, but for a reason, right? Good. Any questions? No. All right. So I'll give you guys 10 minutes and I want you to try and work number 23, right? This one. Let me read it out. A ball is thrown vertically upwards at 40 meters per second. Calculate A, the greatest height attained, B, the time taken to return to the ground, C, its velocity after 3 seconds, and after 6 seconds, and D, the distance traveled during the first 3 seconds, right? So take a 10 minutes, work this question out, and let me know if you're stuck along the way, all right? Okay, you guys finished?
Yes, sir.
Okay, you got the same answers, right?
Yes, sir.
All right, good. So it shouldn't be too hard. Let's just continue on to the projectiles question. All right, so you guys have a test. When is it? Is it tomorrow? So you're gonna want to focus on this question, right? Number 31. Right? For the test. Very good. So let's just start. A shell is fired with a velocity of 600 meters per second in a direction inclined at 70 degrees to the horizontal. Calculate A, the horizontal and vertical components of the velocity. B, the greatest height above ground attained by the shell. And C, the horizontal distance traveled by the shell before it touches the ground. Assume the ground to be level and air resistance to be negligible. Right? So they want us to assume that the ground is level and air resistance is negligible. Right? So what air resistance refers to is, let's say there was a cannon or a gun or something here. Let me draw a gun. And someone fired a bullet. Okay? It's a bullet. Right? Air resistance, right? Air resistance is what would cause this bullet to slow down. But for this question, they want us to assume air resistance is negligible, okay? Equals zero or almost equals zero. Now, another thing is that they want the ground to be level. So when we think of level ground, we think of very smooth horizontal ground. So if something is fired from, let's say, a cannon, right, it would land in this same horizontal line, right? Right, same horizontal line. There isn't any kind of crater causing it to go down further or any kind of mountain that would affect where it lands, right? So yeah, assume the ground to be level and air resistance to be negligible, right? All right. So the first thing, part A, the vertical and horizontal components. So the velocity is 600 meters per second, inclined at 70 degrees. So velocity as a vector, let's draw that. 600 meters per second. Let's draw this right here at 70 degrees, right? 70 degrees. Now remember from last semester, we can break any vector down into vertical and horizontal components. So we can do that here. We can create a right angle triangle, right? And we can say that this velocity V is equal to a vertical and horizontal component. This one could be Vx, this one could be Vy. Vy, the vertical component, Vx, the horizontal component, right? And we use this angle and a trigonometric ratio to find Vx and Vy. So we say Vy is equal to 600 sine 70, right? Opposite. 600 is the length of this line here from here to here, 600 sine 70. And Vx, 600 cosine 70, because here, right, is not opposite, it's the adjacent, so it's 600 cosine 70, right? We plug those values into our calculator, we get Vx is equal to 205.212 meters per second, and Vy is equal to 563.816 meters per second, okay? Now, when we want to find something like part B, the greatest height attained above the ground, because this is a velocity vector and it can be broken up into two components, a vertical component and a horizontal component. When we try and calculate things like height, we need to use the vertical component Vy. So here, Vy. So when we say greatest height, the velocity we're referring to is this 563.816 meters per second. right? Okay, good. So greatest height, we use the formula. V squared is equal to U squared plus 2AS. The velocity is 0 because, again, like throwing a ball up, remember the boy with the cricket ball from the previous question up here, right? Number 22. At the top here, V is equal to 0. Right? V is equal to 0. Yeah. So what we're doing is using that initial velocity, that vertical component of the 600 meters per second, the vertical component alone, and saying that at the point when it's 0, what is the distance? So plugging those in, right? U is that 563.816 squared plus 2 times gravity, right? Acceleration due to gravity, which is 9.81. Multiplying that out, we get S. Multiplying that out and solving for S, we get S is equal to 563.816 squared divided by 19.62. And 19.62 is just 9.81 times 2. Okay? Plug this into a calculator, we get S is equal to 16,202 meters, or in kilometers, S is equal to 16.2 kilometers, right? Okay, good. So number C, part C, the horizontal distance traveled by the shell before it touches the ground. So again, because we're firing this shell, right, at the 70-degree angle, it goes up and it falls down because of gravity, right? It goes up here to some highest height, V is equal to 0. So it obviously travels some kind of vertical height, which we just calculated as 16.2 kilometers, right? And is gonna go some kind of horizontal distance. For this 16.2, we use the vertical component, we use Vy, right? For this horizontal part, we need to use the horizontal component Vx. Now, obviously, you can call this whatever you want, right? You can write out horizontal component if you want. Okay, good. Now, before we find that, we can first find the time taken to reach the greatest height. Now, like the others, let me get some new space here. Like the others, like the cricket ball going up and down, right? A projectile fired at an angle, at a 70-degree angle, is the same way. It goes up and it comes down, and it's somewhat symmetrical, right? Especially when it's on level ground and air resistance is negligible. So the time taken to reach from here to here is the same as the time taken to reach from here to here. Okay, good. So we can find the time taken for the greatest height, so V at the greatest height is 0. Let me write out the formula. So V is equal to U plus AT. V here is going to be 0. Initial velocity U is 563.816, so U plus AT. Solving for that T, we have minus U of course, divided by minus A is equal to T. Minus signs cancel out. We get T is equal to U divided by A, right? Now, the reason we use the vertical component again is because we're finding time for half, right? And when we're finding for the horizontal distance, that's when we bring in the horizontal component. But just to find time, because we already know greatest height, right? Attain, we can use the vertical component with the acceleration, and we know the velocity here is 0, to find the time taken per half. So plugging those values into our calculator, we get t is equal to u divided by a, which is equal to 563.816 divided by 9.81, which is 57.47 seconds. Okay, good. So that's the time from here to halfway, to this point here, this point on top. So that's t is equal to 57.47 seconds. So the time taken to travel this entire distance, and we'll use that time later to find the horizontal distance travel, is 2 times t, right? Because this half here is all to 57.47, right? So this distance here is 2t, which is equal to about 114, right? Good. So the time taken for full path, to travel the full path, is equal to 57.47. Is equal to 57.47 times 2, which is equal to 114.94. Now, to find the horizontal distance traveled, again, we just put in this time and the velocity. Now, we know S is equal to ut plus half at squared. But remember that this a comes from a resistance in the horizontal path, right? So for Vx, that's resisted by a resistance, right? A resistance. But in the question, they said a resistance is negligible, right? So here is going to be 0. So we just get S is equal to ut. And the u in this case is our horizontal component. And the horizontal component we calculated earlier as 205.212 meters per second. Right? So distance, horizontal distance traveled, is equal to 205.212 times 114 seconds, which is equal to 23,587 meters, or 23.6 kilometers. Right? Okay. Now, any questions? Overall? No. All right, so I already sent you guys this handout. Also, all of you should have it. As I said before, the question coming on the test is question number 31, right? So this same question. So you can just follow along in the handout, maybe work it out once more for yourself so that you really understand it. And yeah, good luck on the test tomorrow. All right, so that's all I have for you guys. You can leave.
Thank you, sir.
Good.